Are you familiar with the true, original intention behind mock objects? Because I don't think tests using them are primarily about finding bugs. Although they do that too, mock objects are a design tool to enforce or police a particular interaction between classes. So in today's guided learning hour, we're going to go through the theory and use mocks in a hands-on exercise to get a better object-oriented design. Hi, I'm Emily Bache. I'm a software developer and creator of Saman Coaching. Welcome to my channel. This video is sponsored by Tuple, who make an app for remote pair and ensemble programming for both Mac OS and Windows. And I'd like to show you just how smooth it is. So I'm going to call up my friend Jack to help me with this bit of code. Hi, Jack. So I can just share my screen with one click and then he can look at the code and help me out. Yeah, I spotted something he wants to change there. And Jack can just dive right in and start editing in my machine on my code. And we can collaborate really well. So do check it out. Go to their website. There's a link in the show notes. This guided learning hour is designed to be done together with other people in your team. And the focus is on coding skills and team building. If you haven't seen one of these before, do watch right to the end because the last part is a session briefing and I'll explain more. Let's go over to the shared online activity board where I've got materials prepared. Let's begin by discussing how you might approach testing this piece of code. So in a minute, I'm going to ask you to go into groups and talk about how to test this. There are some comments in the code indicating where there are bugs or in fact missing features of this code. But before I send you out, let me just explain that the context here is we're developing a system for an online auction where different parties are going to bid to buy a product of some kind. And this class here, the auction message translator that you've got the code for here, is going to receive messages from an external source about the progress of a particular auction, whether it's there's a new bid arrived in the auction or whether the auction is finished and somebody's won. And the job of this class then is to parse those messages and pass on the information about what's happening to a listener, which is also not developed yet. So go into your groups and talk about, well, how would you approach driving the development of this using tests? Of course, I don't know what you've been discussing in your groups, but I expect somebody will have pointed out where you're going to probably need different test cases for the different kinds of message that this auction message translator needs to translate. So that's good. But I hope you've also discussed what to do about this listener, this interface that's currently empty that you're looking to develop, and what to do about these comments in the code where it says, well, we're supposed to notify the listener at this point. So what we need to do here is decide on how to divide the responsibilities between this class and the auction event listener. And we need to do some design. What methods are we going to have in that auction event listener interface? So one way you could do this, it's not the only way, but one way is to work with a test double to replace the auction event listener in the test case. So a class that the test controls that fulfills that interface that can help us to design what methods that should have and to check when we've developed the auction message translator that it is interacting with that class correctly. Let me explain. Now, we've talked in previous learning hours about test doubles, so hopefully this is familiar to you. We use a test double in a class usually to test a class that has a dependency on something else, and it's inconvenient to use the real class. So we replace it in the test with a test double that acts the same and looks the same as the real class, but is under the control of the test. So it's a bit like in a film with a stunt double. The person you see on the screen might not actually be the famous actor that you think it is. It's somebody else who's more expendable, and you are fooled, basically. You don't realise it's not the real one. And it's the same with a test double. The class being tested doesn't know that it's not the real one, and it allows the test to control what's happening in more detail. So in this case, what we're talking about here is replacing the auction event listener with a test double and passing that substitute class to the auction message translator in these tests. Let me show you how to do that in a demo. In this demo, I'm going to show you the auction test design kata. This code was inspired by the example in Steve Freeman and Nat Price's book, Growing Object-Oriented Software Guided by Tests. Now, of course, you may not be using the same programming language and tools as me, so what's important to watch out for is the way I'm using mock objects. They enable me to design in the tests, just in the same way as Steve and Nat do in their book. On the left here, I've got the code we looked at earlier with the auction message translator, the code we want to try and test. And then on the right, I've made a start on that test case, and I've just got some example test data of 2 actual messages I could have to process. I've got a test for each, and they're both passing because they don't do anything yet. So let's do some work on this first test. And I'm actually going to start by defining a mock listener, because I know that I'm going to need an auction event listener, and I'm going to replace that with a test double, in this case a mock, and I'm going to write that by hand. In many cases, of course, I might choose to use a mocking framework, but for this demo, I'm going to do it all by hand so I can show you the exact details of what a mock is and what it needs to do. So that class doesn't exist. I'm going to create it just here in the test. And then I'm going to do what you do with mocks, which is set expectations on them. I'm going to say to this mock, you should expect a call to auction closed. And that was a design step. I was just deciding that the listener should have a method, auction closed, and that it should be called when this test executes. And I'll get to what's going to call it in a moment. But first, let's just add this method to the interface. And what I'm going to do basically is just record that this call is expected. I'm going to add a field for that, of which call it is I'm expecting. And now, of course, I need to create the class under test, the auction message translator. So I'm going to need an instance of that in order to test the process message. And I'm going to need to pass my mock to the constructor. And of course, it's complaining because I forgot to tell it that this actually is of the right type. It's going to implement that interface. Okay, so now I've got one of these. I can do the act step in my test. I can call process message. And then at the end of the test, where you'd normally expect to see an assertion, I'm going to ask my mock to check its expectations. Now, if I was using a real mocking framework, this might be an implicit step that was automatically done by the framework. But because I'm rolling my own here, I need to explicitly have a step to check the expectations before the test finishes. So let's implement that here. I'm going to, in my check expectations, I'm going to basically check that the call I expected did happen. And of course, I'll need to compare that against the actual call. I'm going to have a data member for that in a moment. But if it doesn't match, if I didn't get the right call, I should throw an exception and fail the test. And the exception should have a suitable message about what I was expecting and what I actually got instead. So I'll just put that in. And now I really must create this actual call data member here, field. And that means that my code now should be compiling. And actually, I think this test will fail when I run it because my mock listener is expecting a call and it's not going to get it. There we are. I got that exception. Cool. So now, of course, I've got a failing test. The next step is to make it pass by updating the production code. So I can put in some code here to actually call my listener and tell it that the auction is closed. So I already did the design here really to decide that it was going to be called auction closed when I define the test case. So now I just need to add that method to the interface there. And of course, that will prompt me to implement it in my mock. And at this point, I just need to record that I did get the call now to auction closed. And when I run my tests, of course, they pass because I got the call I expected. So I removed that bug or that missing functionality. I added the call to the listener. So I've made some progress. I've got my first test written and passing, so I'm going to make a little commit in celebration. So I have the code now to notify the listener about closed auctions. Are you enjoying the session? Please remember to subscribe to my channel and like the video. What we all want is higher quality code, so we can deliver better software more reliably.
And it takes skill to use mock objects properly and do test-driven development. And training sessions like this are a great start, although it can be considerably more difficult to do TDD in your production code. It could help to get support from someone with experience. The Salman Society is the organisation that I founded for technical coaches, and you could get some help and advice. Sign up for our newsletter on the website or come along to one of our free events. Salman Coaching, growing excellence in coding together.
Great. Well, let's have a look at the other test. Now, this one is going to be kind of similar, but this message also has another subtlety in that it needs to pass not only that there was a price update, but what the new price is. I think the listener's at least going to know that. So I need to set my expectations on the mock listener. It should expect a call to price update. That seems like a suitable method name. But as I mentioned, I need to expect also that I'm going to get an argument, and that 192 is what is being passed in that particular message. So let's create this new expectation setting method, and it's going to do nearly the same as the previous one. I'm going to just make a call that I should expect the call to this price update, but I'm also now going to record the argument that I'm expecting. So I need a field for that. Great. Now, let's see, what do I need to do more before this is going to work? Just reviewing my mock. Yeah, so I think the mock might be doing what it's supposed to be doing. Let's add the rest of the test case here. So we need the class and a test. We need an instance of that. And we're going to pass it the mock. And then we're going to do the act step where we call process message and use this message that I prepared earlier. And then again, at the end of the test, we do need to just tell the mock to check the expectations. Okay, so now I should be able to run this test, and I'm expecting it to fail because we are not calling this method. Price update is not being received. So I can go and fix that now. And make a call to price update and pass it an argument. And I'm deliberately now passing it the wrong argument because I want to show you what happens or make sure that I've developed my test properly to detect that, really. So anyway, there we are. Create the new method in the interface. And I need to also add that in my mock because it needs to implement all the same methods as the interface. And there I'm just going to record that I got this call. And that makes the test pass, but I'm not sure I did this so well because I need to also check that argument. And I should do that here in the call to price update where I've got the argument. I can check it against what I was expecting. And if it doesn't match, then I can throw an exception and fail the test, which is what I was hoping was going to happen. So again, I need to create some kind of suitable failure message here to say what my expectation was and what happened instead. Great, so now I should have a failing test. There we go. And it's thrown that exception. And one advantage of having your expectations here in the actual implementation in the mock is that the stack trace will point you directly at the line in the production code where we had the problem. Here, where I was actually passing the wrong argument. So that's a nice aspect of mocks. Great, so now I've got 2 passing tests and I've got this mock that has the ability to set expectations on it and check if those expectations are met. And of course, it also implements the methods from the interface that now we've got a design for. It didn't before. So the mock has helped us to define that interface and decide what methods it should have. And now I can go away and do some more development, perhaps process different kinds of messages, or perhaps I'll turn my attention to actually implementing this interface and developing that part of the system. In a minute, I'm going to get you all to work on that same coding exercise. But first, some theory, because I don't want you to get confused about what I mean by the word mock. Because in common use, mock just means test double, but actually it's a specific kind of test double. This is a picture from Jared Masaras from his book X-Unit Patterns, where he tries to point this out, that the best umbrella term is test double, and under that you've got stubs, spies, mocks, fakes, and dummies. And today we've been using a mock. Now, just to fit in a little bit more information about each type there, the mock is the one that expects calls. Mocks aren't stubs. Mocks can fail the test if their expectations aren't met. So that's the picture of the policeman there saying stop. But people often confuse it with a stub, which is a kind of test double that just produces specific responses and is very stupid. Mocks are enforcers. They sometimes also need to return fixed results, like a stub would, but you set up expectations on them about the calls that they should get, and then they police those expectations. Mocks are commonly used when you're doing a particular style of test-driven development, which was exemplified in this book, Growing Object-Oriented Software Guided by Tests, where Steve Freeman and Nat Price explain their approach to test-driven development with most of the book is this huge worked example that has inspired this auction test design kata. And the kind of OO design that they do, you could characterize it as tell, don't ask. It's all about telling objects to do things, not asking them for their data. So it's all about which messages the objects are passing to one another and how you distribute the responsibilities between those objects. And you don't really want to have those objects leak or expose the state that they've got. And a lot of classic test-driven development would have you query the state of an object in the assert part of the test. But in this style of TDD, you don't want to expose that state, so you have to find another way to check what's happened, and mocks is the way you do that. Now, in this exercise that I showed you, we were designing this interface, the auction event listener, which at the start of the exercise has no methods in it. So you're using the mock to help you to decide what methods to put there. And you're working out how to distribute the responsibility. And it leads to this other slogan, not only mocks aren't stubs, it's also a good idea to remember, don't mock what you don't own. If you don't own the interface, if you can't change the contents of that interface, then what are you doing using a mock? Because the mock is a design tool for coming up with that interface. So that's where we use mocks. We use it to help us to do an object-oriented design. Okay, so I hope you're now equipped to go and try this for yourselves. You've got the code. Hopefully you can split into small groups to work on this. And there are instructions here on this frame. Basically, you're going to do the same as I did, complete the test for the close message, use a mock. You can use a mocking framework if you'd like, if you're familiar with those, or do it by hand like I did. But be sure to set expectations on the mock and use that to help you to design the interface. And do the same for the price message. And then if you get as far as that, then there is a third kind of message that's talked about in the README in the repo, which you can hopefully also implement. And then you'll get a fuller interface with more methods in it for your auction event listener. Happy coding! Just now at the end of the session, it's your chance to discuss the designs that you've come up with. You've all been doing a kind of test-driven development here with using mocks, and you've all come up with, hopefully, interfaces for the auction event listener that has methods in it. So perhaps take a screenshot of each of your designs and post them on the Miro board so that everyone can see them, and have a little discussion. Do you like what you come up with? Was this a good way to come up with these designs?
Great stuff. So mock objects are a great tool for test-driven development when they're used correctly. Look out for chances to use them to specify interactions when you're designing new code. Happy coding! This is the session briefing intended for the developer or the coach who's going to host this guided learning hour. If you haven't done one of these before, I have another video, Guided Learning Hour How To, which will give you more background. I recently updated it, so even if you've seen it before, it's a good chance to review it again. And of course, don't forget, you can get additional resources from Patreon, including a copy of my activity board, which could save you time making your own. Let's go through all the parts of this guided learning hour.
In this session, there are 3 points where I ask you to pause the video and lead activities with your team. We've got the connect, the concrete practice, and the conclusions. Take a note of how long each one is supposed to take. Now, the connect is not supposed to take a lot of time. This is really for people to read the code and understand the situation that we're in for themselves. So I suggest putting people into smaller groups in breakout rooms so that people can have a bit of peace and quiet to read the code and to explain to one another what they think it does and how they're going to test it. And you might need to just explain again the scenario that we're talking about, an online auction, and this is about designing the division of responsibilities between these two classes. And we need to do this with TDD in this case. Then there's the concrete practice where everyone's going to work on this small coding exercise. So I do suggest that people do this in pairs so people have a little bit more time and space to explore ideas with their pairing partner. You might want to use a mocking framework or recommend to people that they use a mocking framework and use your preference here. But it could be a good idea to make sure everyone's got that installed in advance and knows where the documentation is so they can look up how they're going to use setting expectations on a test double with this framework. And then there is a third message type that I don't show in the demo, but if you look in the repository, the README at the top level has a sample message that they would also need to be able to parse and handle with this code. So that could be a good thing to tackle once you've done the 2 message types I did in the demo. Then there's the conclusions. And if you're a small group, you may want to do this all together and gather all the pairs and get them to share each other's code. So we need to put the code onto the screen where everyone can see it. And then perhaps discuss, well, do we like the method signatures that we've got here? Have these got sensible arguments and names? Do we like the way we've divided the responsibilities for parsing messages versus perhaps bidding in the auction, which is, I think, what the listener is going to do when it gets those messages? And then there's also the wider discussion about styles of object-oriented design. Are you familiar with this idea of tell, don't ask? Are you realizing why we need mocks for this? Because we don't expose state and we don't have assertions on object state. We make expectations about the way interactions happen. So this is what you should be discussing in the conclusions. And as I say, if you're a small enough group, do all that all together, or you could split into rooms if you prefer.
I hope you and your team enjoy this session. Do let me know how it goes for you.